Hi everybody, this is your note on absolute value. It's just a short one-page note explaining what an absolute value actually is and as well what its function looks like. So if we get to the note here, we will see that the absolute value function, it looks kind of strange. It has this vertical lines on either side of x. So the absolute value function is f at x equals the absolute value of x. Okay, so those vertical lines just mean absolute value. So I'm going to fill this in a second. First, I'm just going to kind of talk about what an absolute value is in practical terms. So f at x equals absolute value of x takes x, whatever x is, and makes it positive. Another way of thinking about it is just thinking about the distance of a number from 0. Okay, so it really just has to do with the magnitude of the number, not with whether it's positive or negative. It just cares how far away it is from 0, not which direction it is. So if you can think of a number line where there's 0, let's say we have 1, 2, 3, and we have -3 on a number line. Okay, so the absolute value of 3 is just 3 because it's 3 away from 0. But the absolute value of -3 is also 3 because it's 3 away from 0. So the absolute value line, again, doesn't care if it's positive or negative, just what the actual magnitude of the number is. So it takes whatever's within these two lines and turns it positive. So if it was positive already, it's still positive, but if it's negative, it becomes positive. So for example, if I said, what is the absolute value of -1? It would be 1. If I said, what is the absolute value of 3 minus 5? Well, that would be the absolute value of -2. So it would be 2. Okay? So another way of describing this in terms of a function is that if f at x is equal to x, this is f at x is just equal to x for all x greater than or equal to 0. So if x is positive, then the absolute value of that number is just the exact same thing. So if x is 3, its absolute value is 3. If x is 17, its absolute value is 17. But if x is less than 0, it becomes positive. So you have to think, how does a negative number become positive? So how can we think about going from -3 to +3? Well, the answer is multiplying it by -1. So if your x value is negative, then f at x is actually -x, which turns it positive. So let's think about that here in terms of what the graph would look like. So if f at x is positive, then we have f at x just equal to x. So the absolute value of 0 is just 0. The absolute value of 1 is just 1. The absolute value of 2 is just 2. The absolute value of 3 is just 3. 4 is 4. 5 is 5. Okay, where these are our x values and these are our y values. However, and notice that this is just the line y equals x, which is what we said here, f at x equals x, if x is greater than 0. But if x is less than 0, the absolute value of -1 is +1. The absolute value of -2 is 2. The absolute value of -3 is +3. -4, 4. -5, 5. So this side is actually the line -x, okay? So when you connect This is a continuous function, so we can connect the coordinates. We basically have this shape, oops, that looks like, pretend I'm doing that a bit better. Hopefully you're using a ruler. That looks like a B. Okay, now we can go over to GeoGebra. Okay, and if you want to put this into GeoGebra, you can simply type f at x equals. Now, above my enter key, if I press shift, you'll see I get a vertical line. And you'll notice that GeoGebra creates those two vertical lines for you right away. Okay, and so here we go. Here's our absolute value function. 1 is 1, 2 is 2, like -3 is +3, etc. I'm just going to take that out. Another way of writing it in GeoGebra is f at x equals, and you write ABS for absolute value. And notice this little thing came up. This tells you that yes, you are in fact on the right track and you are writing a function. So absolute value of x, and that works too. So you'll see later when we get to transformations that anything inside of the absolute value sign, like x minus 1, that just moves it left or right. Notice that's just -1 there is a d value. So sorry, 1 is the d value. So it's been moved to the right one. If I do h at x equals the absolute value of x, then +1, where +1 is on the outside of the function, take a gander, what's going to happen? It's a vertical shift up 1 from the original orange function, okay, because the +1 is on the outside of the function. So that just gives you a little precursor to what's going to come with transformations. Okay, so if we continue here with the note, remember, these two vertical lines just make something positive. So when you're having a bad day, all you got to do is this, and there you go. Positive, a positive attitude. So sometimes if I see you looking a little bit down in the dumps, I might just come up and do this to you. Just kidding. Or am I? Anyways, here's just a really quick example. Here's a function, an absolute value function. So we have absolute value of x plus 2 within the absolute value signs, and then we subtract 4. So we always want to deal with what's going on inside the absolute value signs first. Think of them kind of as parentheses, and then we're going to do the -4 after. So if we're putting -5 into the function, we're going to get -5 plus 2 within the absolute value sign, and then the -4 still stays out there. So -5 plus 2 is just -3 minus 4. So now we just think, well, the absolute value of -3 is 3. So my final answer is -1. So in this function, the coordinate would be -5, -1. Okay, you can think about this would be an absolute value function that's been moved left 2 and down 4. You don't need to know that for this note, but I'm just kind of giving you a precursor. So yeah, so this absolute value function would look something like this. So it's just been moved right 2, down 4. So it makes sense that at -5, you'd be at -1. Okay. All right, so the second question is just to kind of think about what this does to graphs. So remember, the absolute value signs make things positive. So x squared minus 4 as a function just by itself. Let's think about what that looks like. That's just an x squared function that's been vertically translated down 4 units. So it has a vertex of 0, 4. Sorry, 0, -4. And it opens up. Okay, so basically looks, oh, you know what, let me undo that. I can do better. Let me go from here. So it looks like this. It's a parabola, right? There we go. That's f at x. So what is going to be different about g at x if it's just the absolute value of f at x? Well, it's going to take all of the points and make them positive. So notice that from here over, all the points are positive already. And from here over, all the points are positive already. Okay, so that will still look the same. But what's going on in this section here is that they're all negative. Okay, so let's pretend like this is -1. Well, that absolute value will become +1. This is like -3, let's say. That will become +3. It goes down to a minimum of -4, so that will go up to a maximum of +4. And then that same pattern will repeat on the other side. So in the middle here, it's actually going to look like this. It's just a reflection, where this point here is 0, 4. Because again, what those absolute value signs do is they take what is negative, so these negative y values, and they make them positive. So this is your graph of g at x. Okay, if you flip over to GeoGebra again, I can just X out of these. You can verify your work. Okay, we can check x squared minus 4. Oops, I didn't make that. Okay, g at x equals x squared minus. That's not. It's being a little bit persnickety there. I just want to get it. So there we go. Minus 4. There we go. There's our x squared minus 4. And then we can do the absolute value of x squared minus 4. And there you'll see it's the green, okay, which is what we just drew. All right, so you can play around with that if you want on GeoGebra. You can graph different functions and then see what the absolute value would be. In this case, instead of doing it this way, I could have done f at x equals the absolute value of g at x, because I've referred to g at x up here, and it will do it for me again. So you can change g at x then to whatever you want and just play around and have some fun, see what that looks like. Because, you know, I'm sure you have nothing better to do with your time than play around with this. There's another quadratic. You could try reciprocal functions, sinusoidal functions. Think about what that would do. You know, just have a grand old time. Anyways, that is your note on absolute value. You can also head over to purplemath.com and search absolute value if you'd like to learn more about what that is, if you found anything confusing. And, you know, I really just have to thank you for watching, and I hope you learned lots.